So as per the definition of AMU, that is atomic mass unit, it is 1/12 of the mass of C12 atom. Based on this definition, we have assigned atomic masses of different atoms. For hydrogen we have 1 AMU, for carbon we have 12 AMU, and so on. Now we are going to next subtopic, that is you have average atomic mass. Now why this average atomic mass is coming into picture? Every element has different isotopes, as I said. Now depending upon the percentage of isotope available in the nature, we have different average atomic mass. For example, I said carbon has C12 and C14. That means C12 will have the mass number 12 and C14 has mass 14. So these two are different. However, in nature we have 98% of C12 only. Only 2% is C14. However, this do contributes for the average atomic mass. So when we have more than one isotopes for any element, then average atomic mass comes into picture. How we define average atomic mass? Average atomic mass is simply an average of the product of the atomic mass of each isotope and their percentage availability in the nature. For example, I mentioned this carbon 12. This carbon 12 is 98% available in the nature. That means I will just multiply here 98 into 12. 12 is the mass of carbon and 98 is the percentage availability of that particular isotope in the nature, plus, because it is average, I am adding it, 2 into 14. 14 is the mass of C14 and 2 is its percentage availability in the nature. Then we have divided by 100. That is going to give me the average. So if I look at this, it will come out to be somewhere around 12.01 AMU. Now this 12.01 AMU is called as the average atomic mass. Now in general, when I have the atomic mass of isotope 1 as M1 and the percentage availability in nature as X, and for second isotope the mass of the isotope is M2 and percentage availability Y, and so on, I just have to take average of all that will give me average atomic mass is equal to M1X plus M2Y plus so on, divided by X plus Y plus, say, let us take only 3 terms here, that is M2, M3Z, so that is the third isotope. This is a general equation which I am writing. So when you have 3 isotopes for particular element which have the mass M1 with abundance in the sense availability in the nature X, and the second isotope which has mass M2 and percentage availability Y, and the third isotope M3 and the percentage availability Z, I just have to divide the sum by the sum of total availability. This will be 100% because always the denominator will be 100 only, because I am taking the percentage availability here. So this will give me the average atomic mass for that particular element. Next we are going ahead with molecular mass. Like I have explained in the previous topic also, when we were discussing law of chemical combination, when we have so many elements, we have so many compounds. So when we have compounds, naturally we cannot discuss atomic mass unit, because atomic mass unit for only element. So when we have compound, we have something called molecular mass. Because every compound is a molecule. Compound is a collection of atoms which is a molecule. So the mass of a compound is taken as molecular mass. So let us take the example of glucose, which you all are aware of, that is C6H12O6. So this is a compound made up of carbon, hydrogen and oxygen. I have 6 carbon, 12 hydrogen and 6 oxygen combining to give one molecule of glucose. Now molecular mass is simply the addition of the atomic masses of all these atoms. So it is very simple. I have 12 carbon, we have 6 carbon, each having mass of 12 atomic mass unit, plus I have 12 hydrogen, each having mass of 1 AMU, that is atomic mass unit, and we have 6 oxygen, each having the atomic mass of 16 atomic mass units. So if I do simple calculation and add it, it will give me 180 AMU. So this is going to be its molecular mass. So my glucose molecule, one molecule of glucose will have 180 AMU of mass. Now some textbooks, especially the edited version, the updated version of SI units, say that instead of AMU we simply use U, which is called as unified mass. So that is why I have used here U instead of AMU. So instead of writing 3 letters, we are writing 1 letter. It is much easier. However, the meaning remains the same. U is unified mass, which is actually atomic mass unit only. So the notation just have to be changed. So this is the updated version. So let us be updated.